Hello everyone, welcome to my channel. Let's learn computer science. Hello everyone and welcome back to my channel. Let me start today's session with a simple question. Imagine you order a product online. Before the parcel reaches your house, three things are needed. First, the delivery company needs your address. Second, the parcel itself must be transported. And third, instructions such as deliver today, handle with care, or maybe urgent delivery must also be communicated. Now, believe it or not, something very similar happens inside a computer. Whatever the CPU wants to communicate with memory or an input output device, it needs pathways to transfer information. These pathways are called buses. Today, we are going to understand one of the most important topics in Unit 4, that is processor fundamentals, system buses. So let's begin. First of all, what is a bus? Before learning about the three buses, let's first understand what a bus actually is. A bus is a communication pathway used to transfer information between components of a computer system. Think of it as a road that connects different parts of the city. Inside a computer, the CPU, memory, input output devices are like different locations, and buses are the roads connecting them. A bus consists of multiple wires running in parallel, with each wire carrying one bit of information. Now, here is a very important exam point. A bus is not a storage device. A bus, it does not store data, and bus only transfers information from one component to another. Students often lose marks by saying that a bus stores data. Remember, it does not. It only transfers information. Okay? Now let's talk about system bus. For a computer system to function correctly, the CPU, memory, and input-output devices, they must communicate with one another. The communication takes place through system buses. System bus provides pathways that allow addresses, data, instructions, and control signals to travel throughout the computer system. Now, system bus, it consists of three buses: address bus, data bus, and control bus. Together, these buses allow data to move throughout the computer system. Have a look at this picture. So here it is displayed how all three buses, they are connecting different parts or components of a computer system inside the CPU. Now let's have a look at them one by one. First of all, let's start with the address bus. Imagine you want to visit a friend. Before you can travel, what do you need? You need the address of your friend's house. Similarly, before the CPU can read data from memory or write data into the memory, it must know the exact location involved. The location is identified as address. The address bus carries these addresses throughout the computer system. Its sole function is to carry an address from memory address register to the memory controller or an input-output controller. So basically, addresses, they identify memory location that is to be read from or written to, an input device that is to send data, an output device that is to receive data. Okay. So functions of the address bus are: it carries memory addresses, it carries input output addresses, it identifies the source or destination of the data. In fact, address bus has a connection with memory address register. Remember registers we covered in one of my previous videos. So you can revisit your concepts by watching that video again. So address bus is connected to the memory address register, and the memory address register stores the address of the memory location that is about to be accessed. So the address bus then carries that address to memory or an input-output controller. In simple words, the address bus tells the computer where communication need to take place. Now, very, very important thing is direction of data flow. Remember, the address bus is the only bus that is unidirectional in nature. Rest both the buses, control bus and data bus, they are bidirectional. So this is because addresses, they can travel in only one direction. From CPU to memory or to input-output controller, addresses are not sent back to the CPU. That is why address bus is unidirectional. Remember, there are many a times questions based on this topic. Another important concept is bus width. The width of the address bus, it determines the maximum number of memory locations that can be addressed. For example, a 16-bit address bus can address 2 raised to power 16 memory locations. A 32-bit address bus can address 2 raised to power 32 address locations. So the wider the address bus, the more memory the processor can access. Okay. Now let's talk about data bus. Once the computer knows where the data is located, the actual information must be transferred. This is the job of the data bus. The data bus carries the actual information being transferred between components. That information may be data, instructions, numerical values, addresses. Okay. Data bus basically allows communication between the CPU, memory, and input-output devices. While the address bus provides the destination, the data bus carries the actual content. Right? Now, functions of the data bus, as we have already discussed, it is to transfer data between the components, transfer instructions between memory and CPU, transfers results produced by the CPU, and it has connection with MDR, Memory Data Register. Now, MDR, it temporarily stores data that has just been read from memory or data that is about to be written to memory. So MDR acts as a buffer because data transfers inside the CPU are much faster than transfers outside the CPU. Now let's talk about direction of data flow in data bus. Unlike the address bus, the data bus is bidirectional. This means data can travel in both directions, from CPU to memory, from CPU to input-output devices, and vice versa. Width of the data bus determines how much information can be transferred at one time. For example, a 16-bit data bus transfers 16 bits at a time. A 32-bit data bus transfers 32 bits at a time. 64-bit data bus transfers 64 bits at a time, and so on. A wider data bus allows larger word lengths to be transferred and can improve computer performance. Now let's move to the third and final bus, the control bus. Imagine a teacher conducting an examination. The teacher announces, start writing, stop writing, submit your papers. These instructions coordinate the actions of all students, right? Similarly, the control bus carries signals that coordinate activities throughout the computer system. So, if we talk about functions of the control bus carries read signal, write signal, interrupt signal, timing signals, clock signals, etc. These signals ensure that every component knows exactly what action to perform and when to perform it. Now, the control bus is connected to the control unit directly. The control unit, as you all know, generates control signals and sends them through the control bus to the other components. Right? The system clock generates timing signals that are carried along the control bus, and these signals, they ensure that data is transmitted at the correct time, data is received at the correct time, and all components, they remain synchronized. Without these timing signals, computer operations would become unsynchronized and the computer would fail. Now, the control bus is also bidirectional. Signals can travel both ways, CPU to memory, CPU to input devices, CPU to output devices, and vice versa. Okay. Here I have created one summary table for all of you. Just have a look. Sometimes you have very direct questions which are based on this summary table. Address bus, it carries addresses. Data bus carries data and instructions. Control bus carries control and timing signals. Address bus is unidirectional, and rest, both the buses, data and control bus, they are bidirectional. Now I'm just showing you one past paper question. Have a look, solve it, and then I'm going to show you the marking scheme. It's a very easy question. So it says the processor uses buses in the fetch execute cycle. The diagram shows 3 buses and 2 descriptions. Draw one line from each bus to its appropriate description. Now, tell which bus is unidirectional and which bus is bidirectional. We have just covered it. So I'm sure you are able to solve it. So I'm just showing you the marking scheme. Have a look, compare your answer, and give yourself marks accordingly. Right. So address bus is the only bus which is unidirectional. Rest, both the buses are bidirectional. So if you look at the mark scheme, 1 mark for 1 correct connection and 2 marks for 3 correct connections. So you have to match all 3 buses with the right description. So that's all for today. Thank you for watching. In the next session, we'll continue our journey through processor fundamentals. Until then, keep learning and keep exploring computer science with CS with SKS. Thank you so much. Take care. Bye-bye.